we want to prove is what? Oh yeah. Want to prove that angle one. Want to prove that AC equals BC. We basically want to prove that it's an isosceles triangle. But so by proving that the angle, CAB equals the angle CBA, that's proving that it's an isosceles triangle. So we're going to try to prove this. Okay, so that's my target to begin with. So what I'm going to do is I'm just going to take just a shot at this one here. Just want to reuse this and make it larger further down the page. Okay, so what we have here is this diagram. So we're going to have to make it larger. So always make a larger version of the diagram you're given. So here it is here. Okay, cool. Now just going to enlarge this so that I can start working with it. Now, first things first, this angle 1 equals angle 2. That's no bother there. Okay? Angle 1 equals angle 2. Given. Okay? Next thing I'm going to do is going to construct a line going from D to E. I've already been given that DC equals CE. So therefore, angle 4 equals angle 3. Reason being, isosceles triangle. Okay, now call this angle 5 and angle 6. Angle 1 plus angle 4 plus angle 5 equals angle 2 plus angle 3 plus angle 6. Therefore, angle 5 equals angle 6. Label this point P. It therefore follows that DP equals PE. Okay? So the two of them are the same length. Okay? Next thing I'm going to do is going to go down here, and angle 7 will equal angle 8. Angle 7 equals angle 8. Reason being, opposite. I'm now going to draw out the two triangles for you. Okay? I'm going to draw out the triangle. I'm going to draw DAB going that direction, and I'm going to draw PEB going in the other direction like that. See the two of them there? This one here and this one here. Okay. Now, what I have already is that angle 1 equals angle 2. Are we happy with that? I can then call this angle. I'm going to prove they're congruent. Sorry? Yeah. So just give me a second here, okay? So I'm just going to label them all. A, P, D, and the other one is E, P, B. Okay, and I already know that angle 7 and angle 8 are equal. So what I'm going to prove is they're congruent. So triangle PA, what's that again? DAP equals triangle PEB. Let's prove this once and for all using ASA. Okay, I'm going to have angle 1 equals angle 2 given. Then I'm going to have that looks too much like a P. DP equals PE. We already proved that further up. And then the other one is angle 7 equals angle 8 opposite. Therefore, ASA. Triangles are congruent. Now, so triangles are congruent, okay? Therefore, it follows that what two sides are equal to each other? AP and PB. Would you agree with that? AP and PB. Therefore, it follows that AP equals PB, and therefore it follows that call this Oh yeah, I need that to be 9 and 10. This one to be 11 and 12. That also proved DAP and PEB being congruent proves that angle 9 equals angle 10. So I'm just going to put therefore it follows that angle 11 equals angle 12. Angle 11 equals angle 12, and because and then angle 9 equals angle 10. Now, if you go to what we're really trying to prove at the very beginning, so I'll just control and group this together, make it smaller. What we're trying to prove at the very beginning of the question was, when I go all the way back, very top, I'm trying to prove that CAB equals CBA. CAB is angle 9 plus angle 11 equals angle 10 plus angle 12, and we already know that 11 equals 12 and 9 equals 10. Hence, proven. Okay, you could just reduce it down to, you could just say it's the same thing as angle 10 plus angle 11 equals angle 10 plus angle 11. They're probably equal to each other, hence they're the same. Is that alright? Okay, took it long enough, had to use every ounce of information I could find to do it. Okay, do you have a way of doing it? Next one. 66PQ is the diameter, circle K, R is a point such that PR is the same as PQ. PQ is the diameter and PR here. So that is parallel to that. Okay? Now, what we can, so I'm going to do a construction. Because it's an isosceles triangle, when you draw a line going down, you're going to draw a line going down at 90 degrees. Because it's an isosceles triangle, it's guaranteed to cut this guy in half, only because it's an isosceles triangle. And your triangle won't do that. Okay? So then you're going to say, what are we looking to do? Prove that RQ... Sorry?
The circle bisects it.
Okay, circle bisects RQ at S. Alright, so we have to prove that this is basically 90 degrees.
We have to prove that RS is equal to SQ.
Okay, so let me see where I did this.
You just proved there how many bodies are SAS.
Yeah, you don't know if you don't know if it's guaranteed to be 90 degrees.
Oh yeah.
But do you know that? That's what I was trying to say with the last one, and you were just like, oh, just draw.
Because it's isosceles triangle, you can guarantee this 90 degrees.
But can you guarantee that S is in the center?
I'm not going to use that. What I'm going to use is my whole goal here is to triangle SPR is equal to triangle PSQ. Connor, you're only allowed to use this in this case because it's an isosceles triangle. Any other triangle, it's guaranteed not to do that.
Yeah, I got that last night, but I just didn't know if
okay, do you ever allowed to use it or not? Okay. So what I'm going to say here is that RP is the same thing as PQ, given. And then I'm going to say that PS equals PS common. And then finally I'm going to say that angle PSR equals angle PSQ, and the reason for that is 90 degrees. I then have RHS. Remember what RHS is? If you have the right angle, you have the hypotenuse, and any one of the sides that are the same, you can prove that they are congruent. So hence SPR, hence triangle SPR and triangle PSQ are congruent, and if they're congruent, hence it follows that, means these three dots means it follows that, or hence PRS equals SQ, hence, like using hence, hence RQ is bisected at S. Everybody happy with that?
When it's a right angle triangle, is it wrong to say side angle side? If you have the hypotenuse.
Side. No, because side angle side would have to be here.
Alright, okay.
Has to, side angle side is sandwiched in between.
Alright, okay.
So you couldn't use that, has to be RHS. Okay. Okay guys, number 67. Okay. It gets actually the last, don't get too disheartened, the last like 5-6 questions are really easy, like 72 to 78 are really easy. It's 60 to 70 is the hard stuff.
Really?
Yeah.
Are we actually going to go on to the next exercise?
Okay. So what we're looking at is proof that PQR and PNM are similar. So how would you go about doing this? We're going to draw two triangles here. Okay, so we'll just draw them out longhand here. So there's that's a PQR and the other one is PMN. Now this should be easy enough for you. Okay, red equals red, PQR, PMN. Okay, blue equals blue, and by process of elimination, green equals green. Now you're gonna have to write that down properly.
At least two angles.
That's what I thought.
Sorry?
At least two angles.
Not congruent. You're just looking for yeah. That's it. Yeah. So PMN. So all you have to do is this. You can just say that angle QPR equals angle MPN. Reason? Common angle. Okay. Next one is angle PQR equals angle PNM. Reason? Given. And then you can just say hence they're equiangular. But if you want just to put the finishing touches on it, we can say is angle PRQ equals angle PNM, or say PMN. Reason being must add to 180 degrees. Okay, and a triangle must add up to 180 degrees. Done. Therefore, proof that PQ over PN equals PR over PM. Okay, so what we're going to do is just keep looking at your colours. Okay, PQ is in between blue and red. This is a really easy way of doing it. Okay, the colours are brilliant. Okay, so pick in the other triangle, pick the one that comes between blue and red. PN. Next one, pick another one, PR, because PR is in the answer. PR is in between blue and green. Pick the other one that comes between blue and green. PM. And just cross multiply and interchange the two of these, and you get your answer. So you can just interchange them diagonally, and then you end up with your answer. Okay, that's 67 done, and now 70. Okay, 70 is a good one. So if you really want something that's loaded with tricks, 70 is the way to go. Okay, 70 is absolutely loaded full of tricks. Okay, so what we have is two chords, PQ and RS meet in T such that SRP equals QRT. Explain why SRP and QRT are equiangular. This one I couldn't see to save my life for a while, but then just had a fresh look at it, then it hit me. Okay, so what we're looking at here, I'm just going to use numbers this time around, maybe a bit of colouring as well. Okay, angle 1 equals angle 2. Any reason?
Standing on the same.
Standing on the same arc. Does anybody know what that means? Standing on the same arc. It means they have the circle theorem. They have the same start and end point. Blue to blue. 1, 2, 3. 1, 2. See that? Okay, so what we're going to do is want to isolate the two triangles in question to prove the rectangular. Okay, so I'm just going to do, so what is it? It's going to be triangle, what we're looking at, SRP equals triangle QRT. QRT and SPR. Okay, so we've already said that angle 1 equals angle 2. What's the next one? We were given one, were we? We'll call that angle 3 and angle 4. Angle 3 equals angle 4, reason? Given. Same mark. And then finally, by the process of elimination, we call that angle 5 must equal angle 6. Reason being? Three angles in triangle must add to 180. Okay. Next one. Complete the ratio. PR equals RT PS. So I'm going to use my colours again. 2 equals 1. 5 equals 6. Okay. So look at this one. Pick PR. PR is in between green and red. What's in between green and red on the small one? RT. And then pick another one that's in the answer. RS is in the answer. RS is between red and blue. So where's the other one? RQ. And there's your part done there. Okay. Now, this gets a bit more difficult now. Okay. Okay. So what we're going to do next is the next part is really tough. Okay. It goes, prove that PR by RQ equals RT squared multiplied by PT plus TQ. So let me show you how my how your logic will come in here. Okay. So what I have is PR by RQ equals RT squared plus PT multiplied by TQ. Now here's what we have to look at here, guys, okay? I currently have a lot of the building blocks of this. If I cross multiply this, what happens? I get PR multiplied by RQ, which is exactly what I want on the left hand side, yeah? Equals RT multiplied by RS. RS is not present in that answer. RS, therefore, must go. Okay? Look at RS. R starts at here, ends at here. RS is the same thing as RT plus TS. So you're going to change that into RT plus TS. Now, I'm going to get my RT squared, which is another part of the puzzle done. But my main problem is that I don't want RT multiplied by TS. I want PT multiplied by TQ. Do you see that? I have RT by TS, but I want PT by TQ. I therefore have to go up to the triangle, find where TQ is, and find out where PT is. So I'm just going to go back up to the very beginning here. Now I'm just going to rub out what we knew before. Okay, I'm just going to put blue here, or say black and black now, okay? And we'll still call that red and red. So, what I'm going to do is look at RT and see the way PT is in this triangle here to the left, and see the way TQ is on this triangle to the right. If I prove these two triangles are similar, I can then start relating the information back to each other. So let me show you what I'm going to do here. See, the reason I thought of that is, guys, PT is here, TQ is here, and what's the other one? TS is located TS is in here. Okay, so we're going to have to use some ratios. What's the other side? PT. So we're going to have PT. Sorry guys, just 1 second. PT is this one here. TQ is that one there. What's the other two sides we have? RT is located here, and TS is located here. So actually, excuse me, we're going to be using these two triangles here. So if I can prove that these two triangles are similar, I can then try and relate the information back to each other. So let me show you how I'm going to do this. So what I'm going to do first and foremost is red equals red. So I want to prove that the triangle PTS equal and the triangle RTQ, I want to prove they're similar. So angle 1 equals angle 2, reason? Same arc. Angle 3 equals angle 4, put in green. Angle 3 equals angle 4, opposite. Therefore, blue, angle 5 will equal angle 6. And reason being for that, must add to 180 degrees. Let's take the side we want, PT. PT is stuck between where, guys? PT is in between the blue and green. In between blue and green on the other one, that's green by the way, is RT. Pick TQ on the smaller triangle. TQ is in between green and red, and that must equal TS, which is also stuck between green and red. Cross multiply, and you're going to get a PT by TQ equals TS by RT. That thing is the same as that one there. So RT squared plus PT plus TQ, and hence it's proven. Okay, lads, this one here, okay, proof that PR is proof that PQ, which is here, is perpendicular to QR. Has to be a right angle triangle then, doesn't it? And what do all right angle triangles must obey? So it has to obey, I'm going to probably spell Pythagoras wrong, Pythagoras' theorem. I'd look up the proper spelling of Pythagoras before you do your test, alright? So a squared plus b squared to be squared must equal a squared minus b squared to be squared plus 2ab squared. Multiply that out. It's the same thing as a squared plus b squared multiplied by a squared plus b squared equals a squared minus b squared multiplied by a squared minus b squared plus 4a squared b squared, same thing as 2ab with 2ab. Now multiply all that out. A4 plus a squared b squared plus another a squared b squared gives me 2a squared b squared plus b4 equals a4 minus 2 times a squared b squared, because it's going to happen twice, plus b4 plus 4a squared b squared. The 2a squared b squared and the 4a squared b squared plus 2 plus b4, and then that one, they're now equal, aren't they? Hence it's a right angle triangle, hence PQ is perpendicular to QR.